Hello and welcome to today's webinar, where I will show you how to create and coordinate openings in Revit Architectural and Structural models. The Revit plugin ConVoid is an advanced closed and open BIM solution for MEP, structural engineers, and architects. You can run the creation and coordination process with linked Revit files, IFC files, and BCF files. I will record the webinar and upload it in the following days. If you have questions, just use the chat and I will give the answers during the webinar. Let me introduce myself. My name is Pelle and I'm the founder and CEO of Conclass. Conclass is a technology company based in Norway. Our focus is on developing innovative and information-driven solutions in the field of BIM and machine learning. In the next 40 minutes, I will show you a project example. First, I will demonstrate how to create or adopt MEP openings, also called provision for voids. After that, I will show you how to update openings if the MEP engineer modified his model. The next topic is how to take openings in 2D views. After that, I will show you the parameter transfer feature. Then, I will create structural openings in a structural model based on the doors and windows of the architect. Furthermore, I will talk about the automatic quality improvement which ConVoid runs. The final two chapters are the coordination and approval process in ConVoid and BCF issue platforms. Alright, let's begin with the project example where I show you how to create or adopt MEP openings in architectural and structural models. The workflow to adopt openings is identical for architects and structural engineers. In this case, I will start working on an architectural model and later on a structural model. The architectural project is now open in Revit. First, I will show you how to create Revit openings based on IFC provision for voids. You will get IFC files if the MEP engineer is working with a different software than Revit, for example DDS-CAD, Plan-Calnova, etc. Now I'm adding the IFC model in my project as a link. After that, I recommend selecting an opening to overview all parameters. It is helpful if the MEP engineers provide some information about the opening, for example if the element is a generic model, a recess or an opening. But it's not mandatory since ConVoid can work without any parameters and with all Revit categories. With the 3D section view, I can define the scope where to create openings. ConVoid will now only create openings based on the elements in the active view. Now I'm starting ConVoid, and the first thing I have to do is to create a void filter. With the void filter I can filter all reference and host elements used to create openings. Here I have to select the MEP project, which contains the reference elements, in this case the provision for voids. If there is more than one MEP project, I can also do a multi-selection. After that, I have to select the category of the openings. In this case, it's the generic model category. Beneath, I have to select all models with the host elements like walls, columns, beams, etc. So basically my architectural or structural model. Now you have to listen carefully. There is a difference between categories for horizontal and vertical voids. Horizontal voids are usually placed in walls and beams. This means you should just select these categories to create wall openings and openings for beams. But of course, you can add more categories if needed. Furthermore, you have the opportunity to make a more specific selection of the elements based on the family type. This is common if just structural host elements should contain openings. For vertical voids, select floors, roofs, stairs, and so on. Based on that selection, ConVoid will run a clash detection. If ConVoid detects clashes between reference and host elements, I can set the conditions. The first step I have to do is to select the level of the openings. I can choose between the host level, reference level, building story, and the specific level in my project. If you want to create horizontal openings and multiply stories, you should select the host level. I explained the use of the host level in the slide. Here we have a reference element in the center of the wall. Behind the element is the opening highlighted in green-blue. If I selected the host level, the opening will adopt the upper and lower level of the wall. Based on that constraint, you will get the distance between the opening and the bottom and upper edge of the slab. Beside that, you always get the distance to the project base point or survey point. I always recommend using the host level for horizontal voids. The next step is to define the creation mode of the openings. There are 3 options to choose from. If you activate the opening mode, ConVoid will always create a penetration that will run through the entire wall, even if the reference element is not intersecting the wall completely. If you activate recess, ConVoid will only create such openings. The last mode is the auto mode. With that mode, ConVoid will decide if the void should be calculated as a recess or penetration. In addition to that, you can define an oversize to the void. This means the opening will get oversized on all edges. Since I don't want to oversize the openings, I will keep the value at 0. The ConVoid families are already pre-selected. If you rename or duplicate the ConVoid families, they will also be shown in the dropdown. Now I can use the parameter filter to filter the reference elements in more detail, for example, based on the opening type. That allows me to define different conditions for each added horizontal opening type. Apply the same settings to the vertical voids, with one exception. If you are working with ceiling and floor plans, please select the level building story. If you only work with floor plans, you can use the host level. The green symbol gives me the information about how many openings possibly will be created. Now I will jump into the settings. Here are multiply options which will affect the creation process. The first one will reset the approval status of the void to default after ConVoid makes a change of the opening. With the second one, you can cut the opening with a host element. Means you get real openings in walls, beams, floors, etc. I recommend keeping the option deactivated because you can also create a cut with the ConVoid manager at a later stage. The third one is to lock the opening with a host element. This means if you resize or move the wall, the opening will also be moved and resized automatically. If you are an architect or structural engineer and want to adopt the MEP openings, you always have to activate the option Adopt Provision for Voids from MEP. Based on that, ConVoid creates a relation between your opening and the openings of the MEP engineer. This is needed for the coordination and approval process. Down here, you have to modify the limits so that the dimension and shape of the openings will not change. Finally, I'm starting the creation process. ConVoid is now analyzing and placing the openings in my project. "95 openings have been created. Let's have a closer look. As you can see, all openings are represented as a solid, which can also be cut with the host elements. The same applies to the 2D view. The openings have various information, for example, the distance to the slab above or beneath, the material of the host element, the dimension, the date when the opening was created, and by whom it was created. Now let's run the process with the Revit model. I'm just adding the Revit MEP model to my project quickly. I can also define the scope where I want to create openings with the crop view. So let's start ConVoid and do some modifications of the previous settings. Since I'm working in the 2D view, I have to define between which two levels I want to create openings. In this case, between level 1 and 2. Now I just need to select the Revit MEP model. The category generic model is already pre-selected since I did it the last time. I'm hitting the refresh button to run the clash detection. The last thing I have to do is select a new parameter since the Revit element do have a different parameter naming than the IFC elements. As you can see, ConVoid adds just the new openings. The already placed openings will get the status up to date. Okay, let's talk about updating openings automatically. If the MEP engineer does any modification to the openings, ConVoid will track all changes in all models automatically. First, I have to do some modifications to my MEP project, therefore I'm taking over the role of the MEP engineer. So the workflow to create openings as an MEP engineer is almost identical compared to architects and structural engineers. I just have to select different categories and make other settings. If you want to learn more about the workflow, I recommend watching the record of the webinar for MEP engineers. Okay, ConVoid changed two openings and marked one as deleted. ConVoid is not deleting any element, therefore I have to do that manually. I'm just adding a color filter to my active view to get an overview of which elements got changed or deleted. The openings marked as deleted are now highlighted in orange. I can also identify those openings in the schedule based on the status color. Alright, let me delete the opening and let's have a quick look if everything is up to date. Everything seems up to date, therefore I'm saving the project and switching back to the architectural model. The only thing I have to do as an architect now is to load the new MEP model in my project and run ConVoid again. All openings have been analyzed and I'm starting the ConVoid manager to get a better overview. First I will add the color filter. Then I'm deleting the openings marked as deleted. I can filter the openings with a specific status by activating or deactivating the checkboxes. All changes are stored in a change log. Based on that, I can see if the opening got moved or got new dimensions. The next topic is how to tag openings in the plan. We provide a tag family template that can show all relevant information of the opening. You can modify the family or create your own one with the help of the shared parameter file, which we also provide. I will take a rectangular and circular void as an example. The tag shows various information about the opening type, the system abbreviation, the dimensions, the distance to the structural slabs, and a unique void ID. The void ID will always be the same in the architectural, structural, and MEP model. In the type properties, you can display more information in your tag by simply activating them. The most common is displaying a different distance or elevation, for example to the project base point or survey point. I will explain the distances and elevations of the openings quickly. As you can see, the current tag displays the distance to the slab above. In the case of the circular opening, I want to display the distance from the center to the slab above. Therefore, I'm simply duplicating my tag to create one for circular and one for rectangular openings. Now I'm changing the type properties for the circular tag to display the distance between the center and the slab above. If I change the family, you see that the distance to the slab is now shown correctly in the tag. I'm switching to the floor plan to demonstrate the Smart Tag feature. Smart Tag can be used to tag elements of a category and family type. Furthermore, Smart Tag tries to find a free spot for the tag in the plan to avoid overlapping tags and elements. The next feature I will show you is the parameter transfer. In many projects, detailed documentations of the opening with all their information is needed. This includes, for example, the fire rating and MEP system information. Doing the work with ConVoid, you can transfer all kinds of parameters from the host, reference, and level to the openings. Here I have a fire-rated wall. The parameter can easily be transferred to a selected parameter in the opening. In my case, the fire rating parameter. Another parameter I would like to transfer is the system abbreviation. The only thing I have to do is to set up the parameter transfer rules in ConVoid. Here you can define the rules to transfer parameters from the reference element to the openings. Select the reference parameter and then the parameter in the opening. Down here you can define the rules to transfer parameters from the host element to the opening, in my case, the fire rating of the wall. Furthermore, I want to add the level name to the opening. The last step you can do is to rename parameter values in case you want a different naming of a specific parameter value. For demonstration, I will rename the level name. It doesn't matter if the value comes from the host, reference, or level parameter. Besides that, you can add and use your own parameters. Let's check the parameters in the opening. Here it is. All parameter values have been transferred successfully. The system abbreviation, the fire rating, and the renamed level. By switching to a floor plan, you can see that the system aberration is also displayed in the text. Okay, the next topic is addressed to structural engineers. Here I will show you how to create structural openings based on architectural doors and windows. The workflow is straightforward since the way to create and update openings stays the same. Now I'm creating a void filter for structural openings. In this case, my reference project is the architectural model. I'm selecting the doors since I want to create structural openings based on them. We also provide the window and door family, which represents the structural openings. So I'm using the door family and set the parameter value to the category doors. That's it. ConVoid translated the doors to structural openings with the exact dimensions. As already mentioned, this is also possible with Windows or IFC elements. Before I start the coordination and approval process, I'm just adding the MEP openings to my structural model. On this step, I will also show you how to cut openings with host elements to get real openings, and what ConVoid does to improve the quality of the openings. Okay, all openings are placed. I'm starting the ConVoid manager to create cuts between openings and host elements. Simply select all openings on the table and hit cut. ConVoid will now automatically create cuts. You can also uncut the openings again or filter openings which are not cut yet. I recommend doing the cuts only when you want to run a clash detection. Otherwise, I would keep them uncut. The reason why is when you are working with dimensions in a 2D plan. It often happens that you catch the reference of the wall and not the opening. If the cut disappears or the opening gets moved, the dimension may be deleted. You can avoid that by keeping the opening uncut, because then you can be sure that the dimension will have a constraint to the opening and not to the wall. Okay, what does ConVoid do to improve the results? ConVoid runs many quality checks to make sure the openings are placed correctly. Here are the most common things that happen. Sometimes the MEP openings aren't placed 100% correctly in the host element. There can be a little oversize, a minimal wrong location or rotation. The example to the left is a really common problem in structural models. If the MEP engineer created the opening based on an architectural and a structural model, There are often non-structural walls attached to a structural wall. Since the structural model does not have the non-structural walls, the thickness of the opening has to be adjusted. ConVoid will solve these inaccuracies automatically to make sure you will get the correct dimension and location as supposed to be. Let's jump to the last topic, the coordination and approval of the openings. I will first explain how to run the coordination using ConVoid. After that, I will show you how project participants who are not working with Revit can use BCF issue platforms to coordinate and approve openings. I'm still in the role of the structural engineer. I will switch to the architectural model after I have approved some openings. You start the ConVoid manager, and if you haven't added a color filter yet, just add one. Now select one or multiply openings and hit Approve or Reject. I can always add a comment to the opening to explain the issue. Furthermore, I can add and edit a snapshot to explain the issue in more detail. Another helpful feature is the clash zone, to check if there is enough space between the openings. If you like to have a different status color, simply select a new color. ConVoid will automatically update the color in the active view and in the table. Now I can export my results as a BCF file, make a selection of the openings in the table, and run the export to share your results with other project participants. Now I'm done with the approval as a structural engineer. Let's switch to the role of the architect. I'm back in the architecture model. The approval process is identical, but if the structural engineer has already shared his results, I can import these in my project to get an overview of what he has approved or rejected. Therefore, I'm importing the BCF file. The window shows me how many openings got approved or rejected by the structural engineer. By clicking Import, ConVoid automatically imports these results in my project. To display the results of the structural engineer, I'm switching to the view of the structural engineer. Now I have a great overview of all rejected and approved openings to avoid double work. But of course, I can give a different approval than the structural engineer. When I'm done, I will also do a BCF export. Back to the MEP engineer. I can now import all shared BCF files starting with the architectural one. This BCF file also includes the approval results of the structural engineer. But since I got a BCF file from the structural engineer, I'm only importing the results of the architect. After that, I'm adding the results from the structural engineer. Now I can read the comments and make the necessary changes to get approval next time. When I'm done with the changes, I run ConVoid and share my model with the architect and structural engineer again. They just need to update the openings again and continue with the approval until everything is coordinated. Since there may be project participants who are not working with Revit, it's also possible to run the coordination and approval process on BCF issue platforms like BIM-Track, BIM-Sync, BIM-Collab, etc. I will demonstrate the workflow with BIM-Track. First of all, the MEP engineer should export a BCF file. After that, he imports the BCF file on the platform BIM-Track. Now all BCF issues or openings are available for all project participants. In this case, I'm taking over the role of the fire protection discipline. To approve or reject openings, you have to work with the predefined labels. The labels in BIM-Track are called discipline. By editing the issue, I can now add my label Fire Protection Approved. I'm doing that until I'm done with my approval. When everything is coordinated, the MEP engineer can export the results and import them in Revit. Okay, now I'm done with all topics. You can find more information about ConVoid on our homepage and download the free trial version there. Thank you for your attention, and I will answer the open questions now.